So, good evening, guys. My name is Dimuthu Silva, and I'm a systems engineer at WSO2. And in this session, we are going to discuss about the key considerations for a smooth transition when upgrading your Kubernetes clusters. So as you may all know, that Kubernetes cluster upgrades are one of the most common things that you may have come across if you are using Kubernetes to run your workloads. So what do you actually mean by a Kubernetes upgrade? So Kubernetes upgrade is actually a version upgrade. You're upgrading the Kubernetes from one version to another version. So a Kubernetes version looks like this. So there is a major version, minor version, and a patch version. So for example, if your cluster is on Kubernetes version 1.2.20.4, then 1 is the major version, 2.0 is the minor version, and 4 is the patch version. So major versions represent significant changes to the Kubernetes APIs and may introduce breaking changes to the cluster. And minor versions typically include new features and functionality. And patch versions, they contain bug and security fixes. When we are upgrading a Kubernetes cluster, the most common scenario is that we upgrade the minor and the patch versions. So one of the most important things is that we cannot skip minor versions when upgrading. For example, if your cluster is on Kubernetes version, suppose it is on 1.21 and you want it to be upgraded to 1.23. So you cannot directly upgrade it to 1.23. You have to first upgrade it to 1.22 and then to 1.23. So in this session, the key areas of discussion are we are going to discuss about the API version deprecations, unsupported software third-party versions, quota and other limits, PDBs and replica accounts, and also a few other best practices. So let's start with API version deprecations. So as the Kubernetes API evolves, APIs are periodically reorganized or upgraded. And when APIs evolve, the old API is deprecated and eventually removed. So when upgrading a Kubernetes cluster, it is important to be aware of any API version deprecations that may impact your workloads, applications, or custom resources. So if you are upgrading your cluster to a newer version of Kubernetes, it is important to fix these deprecated API versions before upgrading to a newer version. So deprecated API migration guide is available in the official Kubernetes documentation, and here is the link. So this is a very simple example of a Kubernetes API version deprecation. So the batch v1 beta 1 API version of the Kubernetes object cron job is no longer available in the Kubernetes version 1.25. So if we are planning to migrate our cluster to 1.25, we need to use the new API version, that is batch v1, instead of batch V1 beta 1. So that is a simple example. Also, here is another example. The networking K8s IO V1 beta 1 API version of the ingress object is no longer served as of 1.22. So this means if you are upgrading your cluster to 1.22, the networking V1 beta 1 version will not be available. So you will have to upgrade it to the V1 version. So you can see that the API version, we are updating it from beta beta 1 to V1. And also, there are other notable changes as well. The backend in the beta 1 is updated to default backend. And also, the service ports in the service name, service ports in the backend are updated as service name, port number. And also, the HTTP path backend service name is changed like this. So these, we need to consider these changes when fixing the API version deprecations. And we need to make sure to check and fix these API version deprecations before upgrading our clusters. So the next point is unsupported software, third-party versions. So during a Kubernetes upgrade, it is important to ensure that all third-party applications, the images used in the cluster, are supported with the version that you are, with the Kubernetes version that you are planning to upgrade. And using supported image versions, using unsupported image versions can lead to different compatibility issues and also potential cluster upgrade failures. So it is recommended to review and update the third-party applications to versions that are compatible with the version, Kubernetes version that you are going to upgrade. And this will help to ensure a smooth and a successful cluster upgrade. The Nginx ingress control is a very good example of such unsupported third-party software version that may need to be updated before upgrading your clusters. So the Nginx ingress controller is a popular choice for managing ingress traffic in Kubernetes clusters. But the different versions of the Nginx ingress controller may not be compatible with different Kubernetes versions. So therefore, it is important that we ensure that we are using the version of using a version of the Nginx ingress controller that is compatible with the version of the Kubernetes version. So we can check the compatibility of the Nginx ingress version with the supported Kubernetes version with this supported versions table. So this version is available in the official GitHub page of the Nginx ingress controller. So first of all, what you need to do is you need to check the Nginx ingress controller version of the your current the deployment of your current cluster. So suppose Nginx Nginx version is 1.3.0, and so Suppose the Nginx ingress version, current Nginx ingress version is 1.3.0, and the current version of our cluster is 1.22. So we are planning to upgrade our cluster to a newer version that is 1.25. So here you can see that we need to find an Nginx ingress version that is compatible with both the cluster versions, the one we are planning to upgrade and the current version. So we can select 1.4.0, where 1.25 and 1.22 both are supported. And another important point is the quota and other limits. So suppose, if you are using managed Kubernetes services like Azure Kubernetes services, Google Kubernetes Engine, Elastic Kubernetes Search from different cloud providers, you need to be careful of the quota limits and node limits, etc. So when using managed Kubernetes services and when you are upgrading a cluster, when you click the upgrade button, so what usually happens is, so a new set of nodes with the newer Kubernetes version will spin up, and then all the workloads of your current nodes will be transferred and scheduled onto these nodes. And then your current nodes will be upgraded, maybe in a rolling manner. So for this task, we need to ensure that there is enough quota, that is CPU and RAM, also a maximum node limit to auto scale the node pool. All these quota are sufficient for the upgrade to successfully take place. Also, another important point is PDBs and replica accounts. So in order to make sure that our applications do not face any downtime during the cluster upgrade process, we can set PDBs or pod disruption budgets. So with PDBs, you can ensure that your workloads remain available and stable during a Kubernetes cluster upgrade. And with PDBs, we can specify the minimum number of replicas of a workload that should be available at any given time when upgrading our clusters. So we can define these pod disruption budgets, or PDBs, in two different ways. First, we can specify a field called min available, and the next one we can specify it as max unavailable. So, so this is a PDB manifest. Here you have to first specify a unique label for your running application, so that the PDB will be applied to your application. And so suppose your application has 3 replicas. And with this min available to field, it will make sure that there will always be a minimum of 2 replicas available. And the next one with the max unavailable field, this will make sure the maximum unavailable replicas will always be one. Suppose you have 3 replicas, then one will always be one will be unavailable and 2 will always be available. So in both the cases, a minimum of 2 replicas will be available. So we can use this during cluster upgrades to make sure we do not experience any downtime in our applications. Also, these are a few other best practices that we can follow during cluster upgrades. So first, upgrade the control plane and then the workers. So the reason that we upgrade the control plane components first is that they are responsible for managing the state of the cluster, ensuring that the workloads are running as expected. So by upgrading the control plane component first, you can ensure that they are compatible with the new version of Kubernetes, and it can properly manage the upgraded worker nodes as well. And also, second point, we need to make sure to test the upgrade in a lower environment before moving to production. So it is always a good practice to upgrade your dev test clusters first before upgrading your production clusters to identify any potential issues. Also, it is recommended to perform cluster upgrades regularly. Do not wait till the version becomes too old. So performing regular cluster upgrades is important for several reasons. So there are security reasons. The new versions of Kubernetes often include security fixes and patches that address different known vulnerabilities. And we can make sure that our cluster is protected against these vulnerabilities if we do regular cluster upgrades. And also for the stability. So these new versions include bug fixes and performance improvements that can help improve the stability and the reliability of our cluster. And there are compatibility reasons. So by upgrading your cluster regularly, you can ensure that you are running a compatible version of Kubernetes for your applications. And also different feature upgrades. So new versions include different feature upgrades and functionality that can improve the efficiency and the capability of your cluster. So overall, these can help ensure that our clusters are secure, stable, and compatible with the latest tools and applications. So that's about it. So I hope you found this session useful, and thank you for listening.